There we go. Okay. Hopefully this thing stays on the whole time. We'll see. All right, so today we're going to start math. Joy of joys. Everybody's favorite thing. No problem. Do, 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 do. So much paper. Okay. All right. Oh, I must have counted wrong. I had 3 left over. Okay. That's all right. Rather have leftovers than not enough. Okay. Uh-oh. Who got the one that says my copy at the top? Okay. Yeah, I'll slip that out. There you go. All right. I was like, error, Batman, error. Oh, whose water bottle? I'm gonna get this returned to you from day 1. No worries, man. Finally get that out of my car. All right. Stay. Okay. All right, guys, so today we're gonna deal with math. Math is broken into several categories. Today we're doing math part 1, which is called fundamentals, okay? So for those of you who are in like pre-calculus, trigonometry, AP Calc, those upper level math courses, this is where you're gonna spend the bulk of your time because this is all the stuff that you've forgotten from long, long, long ago. We're talking pre-algebra and before, okay? It's not that y'all don't know how to do this stuff. It's that you haven't done it forever, okay? Those of you who are in things like college algebra or math for college readiness, MCR, algebra 2, this is going to be a little easier for you because you've had it more recently, okay? All right, so let's take a little bit of time with this guy. Our goal today is to get through all of this. So we're going to move quickly. So the math section on your SAT is broken into 2 different sections. You have section 3 and section 4. Your section 3 is on the left, section 4 is on the right. Section 3, you've got your non-calculator. Oh, I'm sorry, what's up? It's okay. Resource Center? You found it. But this is the SAT, ACT prep class. Which one are you looking for? Oh, interesting. I have no idea. I don't know because that's not me. Yeah.
This is where it is.
Yeah, you're right. But I have no idea where that's taking place. You're in the right building. Okay. I'll tell you that. Okay. So I would say just hang around and see if somebody else shows up because I don't know who's teaching that. No problem. Interesting. All right. That would be right up my alley. That would be something I would teach, but that's not me. Here you go, my dear. Okay. All right, so back to our stuff. I need a drink. Okay. Reach behind you. Shut that door closed. Thank you, my dear. There you go. All right. Trash can, handy doorstop. Okay. All right, so let's try this again. SAT math, we got 2 sections, section 3, section 4. Section 3 is your non-calculator. You got 15 multiple choice and 5 grid-ins, total 25 minutes. Everybody loves the grid-ins. Okay, section 4, we got calculator. We got 30 multiple choice, 8 grid-ins, total of 55 minutes. All right, so when you look at that, you go, the calculator section is almost double the number of questions of the non-calculator section. So logically, the calculator section should be worth double the number of points, right? That would make sense. No, College Board doesn't do things that make sense. So in order to do well on your math, the sections are scored almost evenly. They're not quite even, but they're pretty darn close. So in order to do well in the math section, on the SAT, you have to do well in both sections. Okay, that's bottom line. All right, as far as your topics covered, I gave you a table there of your topics covered. This is straight off College Board's website. I have no idea why they give you this information, because if you pick up any single SAT test, you'll find it never actually conforms to this table. All right, so what can we actually get out of this information? What we can get is we can at least figure out what's important and what isn't, okay? So the things that are important where we want to spend our time is on problem solving and data analysis. Okay, we want to spend our time working with percents, proportions, statistics. We want to spend our time with hard algebra. We want to spend our time with Passport to Advanced Math. What we don't want to do is spend our time in that last topic. Okay, because the things in that last category obviously are not that important. Okay. All right. Structure. Let's talk about order of difficulty on your SAT. So, have you ever taken an SAT test? Those of you who have already taken it. Have you ever taken one and found that you have this mysterious fifth section at the end of the test? Yeah, I see some of you nodding. Okay. So that mysterious fifth section at the end of your test, that never counts towards your score. Never. No matter what the proctor tells you, it does not count. Okay? Those are experimental questions. Those are questions they are trying out. Okay? I've proctored these things before. I've been trained by College Board. What College Board trains the proctors to do is to lie to you. They tell you to tell the students that it counts so that you guys try on it. Okay? I wouldn't do that. I refused. But you're trained to tell the kids that it counts. So if any proctor ever tells you that that fifth section counts, it's because College Board is telling them to do that. But it's not true. That fifth section is just test questions that they're trying out. Now, the way they determine order of difficulty for the math questions is that the more kids who get a question wrong, the higher the order of difficulty that question gets if they decide to put it in the test. Okay? Now, that sounds like a great system until you realize this. They only use certain questions in certain areas of the country. Okay? Now it becomes completely flawed. What if they try out a question in California and they don't teach that topic in California? Everybody's going to get that question wrong. So then it's going to get a high order of difficulty. It's going to get put toward the end of the test. Now, let's say we teach that topic in Florida. So you get to that question. It's toward the end of the test. You look at it and you go, oh, I got this. I know what I'm doing because we teach it here. But then your brain goes, wait a minute. It's toward the end of the test. This should be hard. It can't possibly be that simple. You psych yourself out. You second guess yourself and you get it wrong. Okay? Do you see where the problem lies here? All right. So bottom line. I don't want you to worry about order of difficulty. You take each question as it comes. If it looks like it's easy for you, it's easy for you. If it looks like it's hard for you, it's hard for you. Okay? Ignore their order of difficulty because the way they determine it is completely flawed. Make sense? All right. Moving on, next page. So that was the SAT. Let's talk ACT. Your ACT math is section 2. It's 60 minutes, it's 60 questions, okay? They are all multiple choice and it's all calculator. None of those lovely grid-ins that you guys love, okay? Questions are not in order of difficulty. They're completely mixed up. So if you get stuck on number 1, don't worry about it. Go to number 2. Now, what we have seen in the last couple years is that the ACT is trying something a little new. The last 10 questions, okay, questions 50 to 60, tend to be reserved for some pretty rough questions. They tend to be pretty hard, okay? Again, that's just a trend that we're seeing in the last year, year and a half, okay? Is it going to continue to be that way? I don't know. We're watching, okay? But just keep that in mind. So if you look at those last few questions, you go, man, those were rough. Yeah, it's designed to be that way right now, okay? All right, topics covered. You have a table here from ACT of the topics covered. Again, your ACT is very rigid. They stick to this. This is accurate, okay? So you pick up any ACT test, you are going to have exactly 14 pre-algebra questions, 10 elementary algebra questions. It's going to stick right to this table. They're very, very rigid with their tests, okay? And it's been this way for over 50 years. They're not changing anytime soon. Timing-wise, let's talk timing on your math test. The biggest hint I can give you on timing is to slow down. Most students go way too fast through the math section. What happens is that you wind up making sign errors and computation errors, okay? And here's the rub. The test makers are devious. They know where you're going to make those sign errors and where you're going to make those computation errors, and they'll put the answers in there that you will get if you make those sign errors and computation errors, because they know what you're going to do. So slow down, just don't make the errors, and you'll be okay. All right, next page. General tips for doing well. Use your process of elimination. Get rid of things that are obviously wrong. There are going to be times where they're asking you, hey, find the length of this rectangle. And there's going to be a negative answer. You can't have a negative length. Get rid of it. Okay? There are going to be times when you can do things like that. Next one down, the directions are always the same. Don't waste time reading them. This is the one time in your life where your teacher's going to tell you don't read the directions. You know how to take a math test. Normal math word problem strategies apply. Read your problem carefully. Note what they're telling you. Note what you're looking for. All that normal word problem strategy stuff. Fourth one down, draw a diagram if appropriate. This is especially important in your geometry section. If they don't give you a diagram, draw one. Pictures help us with geometry problems. Okay, make sure you label the heck out of your diagram or theirs, depending upon which one you're using. Diagrams are to scale unless otherwise noted. Okay, let's talk about that for a minute. So if they're to scale, that means we can use them to estimate things. So say we have something like this. We're looking for the long one. Let's say this is 5, and we got to figure out that. Well, I know it's more than 5. In fact, it's probably about double, so I can say it's somewhere around 10. So somewhere probably between 9 and 11. Okay, I can use that just simply to estimate it. Now, if my drawing says figure not to scale, and they give me an angle like this, and I got to figure out what the angle is. And if it says not to scale, on the SAT, this could be an obtuse angle. This could be 120 degrees. It could be that far off on your SAT. Okay? They will screw with your brains. On your ACT, if you see this, you know that that sucker's under 90. They're not going to mess with your brain that much on your ACT. So we're going to know that this is under 90. I just can't look at it and go, it's about 60. I can't do that. But I can at least say it's going to be under 90. Okay, make sense? All right. Okay. Use your test booklet for scratch work. No mental math, guys. Out of your head and onto paper. Okay? Your brains do not catch mental errors, mental math errors, but your eyeballs do. The more you see it, the more likely you are to catch those mental math errors. My worst one, by far, is 5 times 5 is 10. I do that all the time, but if I write it out, I'll catch it. Okay. Estimate to eliminate incorrect answers. Use your scale drawings. And we have an example of that. All right, let's look at the example in the middle of the page. This is about estimating to find your answer. All right, so we have a circle. Kind of an egg, but it'll work. So number 17, we have semicircular arcs, AB, AC, BD, and CD. Divide the circle into regions. The points shown along the diameter AD divided into 6 equal parts. If AD is 6, what is the total area of the shaded regions? So we have this kind of swirly looking thingamajiggy like that. And then the top and the bottom are shaded. Okay. And we know going across from A to D, this length here is 6. All right. And they want the area of the shaded region. So we want the area of the top and the bottom put together. Well, I don't know about you guys, but in my geometry classes, they never taught me to find the area of a swirly thingamajiggy. But that was not on my formula sheet. So we need to come up with a plan B. About how much of that circle is shaded, give or take? Just estimate. What do you think? Well, how much is shaded? How many parts? 2 out of how many? 3. So it's about 2/3. So about 2/3 of that circle is shaded. What's the area formula for a circle? Starts with pi. Pi r squared. Thank you. Okay. So 2/3 pi r squared. There's my area. That's my area of my shaded part. From A to D is 6. So what's my radius? 3. All right, plug in 3 for r. We got area equals 2/3 pi times 3 squared. 3 squared is 9. I need 2/3 of 9. Multiply by the top number, divide by the bottom. 2 times 9 is 18. 18 divided by 3 is 6. This is 6 pi. Lo and behold, I have an answer of 6 pi. Let's see. Okay. That's how we figure this out. Makes your brain work a little differently. But again, we're just estimating. We're like, it's about 2/3. And that's how we have to figure some of these things out. Okay? By the way, this is the only problem in my packet that's more than 2 years old. Okay? Otherwise, every problem you're going to encounter in these packets is less than 2 years old. All right. So, formulas. Let's talk formulas. Jump over to the other handout you have that says all about formulas at the top. Okay, so your ACT, You do not get a formula sheet. You get nothing. So you have a lot to memorize. Your SAT, you are given at the top here, there's a box. That is your SAT formula sheet. That is what you're given in that box on the SAT. Okay? All right. Within that box, let's talk about what you need to memorize for your ACT. You need to, I don't know if you guys can see this, but you need to memorize everything but the last three. So the sphere, the cone, and the pyramid, you do not need to memorize. You can ignore those. You need to memorize the rest of everything that's in that box for your ACT. They will not give you those. So you can ignore the last three, but memorize everything else for your ACT. Okay? The ACT will still use those. They'll use the sphere, the cone, and the pyramid, but if they want you to use them, they will give them to you in the problem. They don't expect you to know those off the top of your head. Okay, the rest of the formulas in this packet are things that you need to memorize for both tests. So, fun and dandy. The way these are organized is that they're organized by packet. So, the algebra packet, which you don't have yet, there aren't any formulas in this packet. So, the packet that you have today, there are no formulas for. But otherwise, they're organized by packet. So, you have algebra packet, you have your quadratic equation. And I put the discriminant in there for you guys. So the discriminant didn't used to be important. But what we're seeing within the last, since like June, May or June of 2020, or excuse me, 2021, last year, we're starting to see more discriminant questions pop up on your SAT. So I put the discriminant in there as something that you probably need to know. That harkens back to like Algebra 1. So right now, I don't want you to worry too much about what these are or how to use them. I just want you to memorize them. Just get them in your brain. As we go through the lessons, you'll learn more about how to use them and what they mean. But for right now, just get them in your head. Okay? These are all things you need to know for the test in March. All right. Most of them you've seen before. There's probably a couple you haven't seen. Okay, so that's your formula packet. Again, just work on getting things memorized. All right, let's get into some strategies. Let's go to page 4 of your main packet. It says 2 main strategies at the top, pick and choose. Okay, so the algebra on these tests is weird. Okay, most of you guys have seen an SAT or you've taken a PSAT. You guys know these tests are strange. So one of the ways we get around doing algebra is with these picking and choosing strategies. We're going to use these repeatedly through all different types of problems. So strategy number 1 is to pick and choose numbers. We're going to use this strategy when there are letters in your answers. So if you look at a problem, you got letters in your answers. Typically, you can pick and choose a number for that letter. Okay, so we're going to replace the letter in the problem with a number. We're going to calculate out the problem using the number we chose and get a target value. We're then going to plug the same number we chose into our answers and see which answer matches that target that we got in the problem. And whichever answer matches, that's the answer you go with. Okay, and I know it kind of sounds like Chinese, but we're going to do some examples and it'll work out. It'll be okay. Before we do the examples, though, I want to go through a suggestion and a rule that we have for this strategy. Okay, and these are the 3rd and 4th bullet points under pick and choose numbers. So your suggestion is to not choose a number that's already in the problem. Okay, so the example I have there is if you have the equation 3x minus 8y equals 6, then when you go to pick the number that you want to plug into the problem, you're going to try to avoid 3, 8, and 6. Okay? The reason we do that is that it tends to lead to a coincidence where more than one answer is going to look like it's right, and I'm going to have to pick a different number and do the problem again. And I don't want to do the problem more than once. I want to be one and done. So that's our suggestion. We will violate this suggestion if picking a number that's already in the problem is going to make my life much easier. And we're going to have examples of that, I think, in the algebra packet. I think is where we find those. We also have a rule. Our rule is the 4th bullet point right there. You never, never, never choose 0 or 1 as the number you're plugging into a problem. Never. Okay? And the reason we don't choose 0 or 1, probably still looking for the class. The reason we don't choose 0 or 1 as the number that we plug into a problem is they do weird things when you multiply or add them. So it completely screws up your strategy. Okay? So let's avoid 0 and 1. All right. We're going to skip strategy number 2 for a minute. We'll come back to it. In the middle of your page, you have an SAT question example. Let's look at that. Denise is 4 years older than her sister Karen, who is currently twice as old as brother Stephen. If Denise is now X years old, what will Stephen's age be in 2 years in terms of X? I hate these problems. I'm like, come here, Stephen, how old are you? Problem solved, I'm done. All right. So, forget it. Let's choose a number for Denise. Okay, I got letters in my answers. I can do this. So, Denise. I'm going to tell you from doing this problem repeatedly that you want to pick an even number unless you love fractions. Okay? You wouldn't know that. I'm just telling you from experience. So, pick an even number. How old is Denise? 6. Denise is going to be 6. I'm good with that. All right, so that goes in your first blank down there where it says pick an age for Denise. Denise is 6. That's my X. All right, Karen, oops, which I can't spell apparently. It says that Denise is 4 years older than Karen. So how old does that make Karen? 2. Denise is older than Karen, so subtract 4. All right. Karen is currently twice as old as brother Stephen. So how old is little Stephen? I didn't hear. 1. I got a 1 back there. Good. Karen is twice as old as Stephen. Stephen's got to be 1. All right, our question is, how old will Stephen be in 2 years? So 2 years from now, how old is Stephen going to be? 3. Beautiful. All right, we have just solved the problem. We have a target. Our target is 3. Our X that we chose is 6. Take your X, 6, plug it into your answers. A, B, C, and D. And see which one gives you your target, 3. Okay? So A says, what is A? X over 2 minus 4. So that's 6 over 2 minus 4. That is 3 minus 4. Stephen is negative 1. Stephen isn't born yet. B, X over 2 minus 2. 6 over 2 minus 2. That's 4 minus 2. That's 2. I'm looking for 3. So A and B are out. C is just X over 2. That's 6 over 2. That's 3. Aha! But I need to check them all. I got to make sure I don't have more than one that's right. D, I got X minus 2 over 2. 6 minus 2 over 2. That's 4 over 2. That's 2. Also not helpful. Got to be C. Okay? That's how we solve these. Any questions? Ma'am?
This works for like most algebra problems?
As long as you have letters in your answers.
Okay.
Yep. Every once in a while you run into one where you can't do it because of the wording of the problem, but most of the time this is quite helpful. We love this strategy. It's a happy thing. All right, we're going to do it again. ACT 21 down at the bottom. All right. Yeah. All right, so ACT 21 says that John has X red pencils and 3 times as many red pencils as blue pencils. If he has 4 more yellow pencils than blue pencils, then in terms of X, how many yellow pencils does John have? Go count your pencils, John. All right. So X is my number of red pencils. How many red pencils would we like John to have? What you got? 2? All right. He's got 2 red. He has 3 times as many red pencils as blue pencils. How many blue pencils is he going to have? No. He has 3 times as many red as blue. Which one does he have more of? He's got more red than he does blue if he's got 3 times as many red as blue. So what do I have to do to my red number? Am I going to multiply or divide? Divide. Okay. So do I really want to do 2/3? No. Okay, no big deal. Reverse. Back up. Pick a different number. What number do I want to pick for my red? Nick? 6. Beautiful. Okay. 6 sounds good. Then how many blue do I have? 2. All right. Let's figure out how many yellow. I don't remember what it says about yellow. Something about 4. 4 more yellow pencils than blue. So how many yellow do I have? 6. All right. The question is, how many yellow pencils does John have? Aha. We've answered that. He has 6. There's target. So my target is 6, but I'm also plugging in 6. That's okay, it happens. So I'm plugging in 6, because that's what my x was, and I'm shooting for a target of 6. So again, back to my answers. A, x plus 4. Well, I'm pretty sure 6 plus 4 is not 6, that's 10. B, x plus 7. 6 plus 7 is not 6. C, x over 6. 6 over 6 is 1. D, x plus 12 over 6. 6 plus 12 over 6. That's, what, 18? You can use your calculator on this too if you need to, but 18 over 6 is 3. E, we've got x plus 12 over 3. 6 plus 12 over 3. 18 over 3. That gives me 6. Aha, it's got to be E. Okay. A lot of times with these, if you're working with smaller numbers, you can do it faster by hand than you can't even punch it in the calculator. All right. Jump packets. Go to your picking and choosing strategies practice packet. Sir.
So on the last question, so if we use like, for example, 9 as x, we would have ended up with, I forgot what I remember, but it's a different number than 6.
Yep.
So like,
This would have been 9, this would have been 3, and 3 plus 4 would have been 7.
so is this what it's closest?
No, you should get 7. If you plug in, if you're going to plug in 9,
Oh, yeah, that's right.
yeah, plug in 9, don't plug in 6. Yeah.
You have like two variables and then a constant that's not variable.
Depends on what's in your answers. Do you just have letters in your answers, or do you have 2 variables in your answers? Yeah, see, that's the problem. It's like, how is the problem set up? Yeah. Yeah. You are actually going to see a problem where you have 4 letters, and you have to pick numbers for all 4. Okay, so there are multiple letter problems where this strategy works. Okay. All right, let's do more. So first page of your picking and choosing, number 1. Okay, first of all, let's talk about what problems you can use a calculator on, which ones you can't. If you look at this packet, your very first problem, there is no little calculator symbol next to it. But the second problem there is. That tells you which problems you can use a calculator on and which ones you can't. Okay, tried to make it simple. All right, if there's a calculator symbol, it's a calculator problem. If there's no calculator symbol, it's not a calculator problem. There you go. So SAT number 13, no calculator symbol, so it's a non-calculator problem. Which of the following is equivalent to the expression 7x minus 4 over x plus 9? I have letters in my answers. I can pick a number. So pick a number for x. 8. Keep in mind, you're working without a calculator. Do you really want to do 7 times 8 minus 4 over 8 plus 9? No, let's go 2. Let's go 2. I had a kid pick 57 once. I said, I'm out. You're on your own. I'm not doing it. All right. So 7 times 2 minus 4 over 2 plus 9. So that's 7 times 2 is 14. 14 minus 4 is 10. 2 plus 9 is 11. Okay, there's my target. And we're doing x equals 2. Always write down what you choose for x. If you don't, you're going to forget what you need to plug into your answers. Happens on a regular basis. All right, again, we're working without a calculator. Look at your answer choices. Which ones are less ugly? A, B, C, or D? What do you want to start with? Which ones are less ugly? Yeah, C and D. Yeah, so I would start down there. Definitely not starting with B. All right, so let's start with D. D's kind of pretty. 7 minus 4 over 9. 7 minus 4 is 3. 3 over 9. That's 1/3. All right, we got 10 over 11. That's almost 1. That's really close to 1. 1/3 is not close to 1. There's no way that those things can be equal. So get rid of it. Let's go to C. 7 minus 4 over 9. Okay, I could get a common denominator and calculate this, but let's just use some common sense here. I've got 7. I'm subtracting 4 over 9. 4 over 9 is about 1/2. Right? 4 is about half of 9. Is 7 minus 1/2 going to give me something close to 1? No. So again, we can just kind of common sense this one out, that that's just not going to work. This is going to be 6 and something. Get rid of it. So D and C are gone. A. Because if I look at A and B, I'm going to do A every time over B if I don't have a calculator. 7 minus 4 over 2 plus 9. That is 7 minus 4 over 11. I can use the same reasoning I used on C. 7 minus a little piece is going to give me 6 and something again. It's not going to give me something close to 1. So get rid of it. Answer by process of elimination has to be B. You're on a time test. You don't take time to calculate something like B. Okay. Little common sense with math goes a long way. All right, any questions? All right, let's do the next one. ACT 17. Yeah, I can read. All right, for all x not equal to 3, don't pick 3. Which of the following is equivalent to this lovely expression in your back in calculator land? Okay, so we don't want to pick 3. Look at your answer choices. Which number, remember, we don't want to pick a number that appears a lot in the problem. Which other number, based on your answer choices, do you also probably not want to pick? Yeah, I would stay away from 2 and 3. So what number would you like to pick here? Let's try 4. All right, so if x is equal to 4, we're going to plug 4 into our problem and get a target. So 3 times 4 squared minus 7 times 4 minus 6 over 4 minus 3. Makes the bottom nice. The bottom's 1. Throw the top through your calculator. I'm going to grab a drink. Somebody throw that through the calculator. Tell me what you get. I heard a 14. Can somebody confirm it? Yep. Cool. All right, target's 14. Oh, I put my papers down. I didn't know what my answers are. All right. Oh, here comes drama. A, we got 3x plus 2. 3 times 4 plus 2. Hey, that's 14. Okay, so A stays. Remember, we've got to check them all, make sure we don't have a double. B, 3 times 4 minus 2. Well, 3 times 4 plus 2 work. 3 times 4 minus 2 is not going to work. C, 3 times 4 minus 2. 4 minus 2 is 2. 2 times 3 is 6. That fails. D. 3 times x plus 2, so 3 times 4 plus 2. 4 plus 2 is 6. 6 times 3 is 18. Also not 14. E, x squared minus 2. 4 squared minus 2. 4 squared is 16. 16 minus 2, uh-oh. That's a problem. I got 2 of them that give me 14. Okay. So, I'm kind of glad y'all picked 4. So this had a coincidence. No big deal. We just won the lottery. Like, this does not happen very often. We're going to have to pick a different number and do this again. But we only have to check A and E. Once the answers are ruled out, they're out. We're done with them. Okay? So, pick another number. What other number you guys want? 6. Okay. All right, so now x is equal to 6. Plug in 6. So 3 times 6 squared minus 7 times 6 minus 6 over 6 minus 3. All right, so obviously the bottom's going to be 3. Somebody run that through the calculator. Tell me what you get. What do you get? 60. Can somebody confirm, please? Okay, thank you. All right, target is 20. Did you get 60 overall or 60 on the top? 60 on top, okay. So, I thought that's what you meant, but I'm like, maybe I better clarify. So 60 over 3 is 20, new target's 20 with plugging in 6. Again, I only have to check A and E. So 3 times 6 plus 2. That, oops, 3 times 6 is 18. 18 plus 2 does indeed give me 20. A still works. E, 6 squared minus 2 is going to be 36 minus 2, that's 34. So E is out. A is going to be my answer. Okay. So now you guys know what to do when you run into one where you get 2 answers. I've never had to do more than 2 numbers. So I've never hit like a double coincidence and had to do it a 3rd time. If you ever do, there's probably something wrong with your method. You probably can't apply the strategy. Or you got really, really lucky. Okay, on your next page, The entire next page, 10, 14, and 36, these are all homework. Okay? Again, you're still applying the same strategy. I am well aware that there are other ways to do these problems. I understand that. The idea with everything in this, the idea with everything in this packet is that you're practicing these strategies. Okay? That way, when you go into test day, it's easy for you to be able to use these strategies. I want these in your back pocket so they're easy for you to pull out and use. No, just the next page. So just page 2. All of page 2 is homework. Okay? And we're going to go on to page 3 because we're going to discuss the next strategy. So stay in the same packet, just go to page 3. Okay, so we've talked about what to do now when there are letters in your answers. Let's look at what to do when there are numbers in your answers. And this is an easy strategy because you've all been doing this since grade school. If you have numbers in your answers, plug them in. Work backwards. Okay? Like I said, you've been doing it since grade school. Plug your answers in. See which one works. We are going to make one minor modification to that strategy. We're going to make it a little more efficient. If your answers are in numerical order, start in the middle. Because if you start in the middle, let's say you start with B, and B is too low, and everything below it is lower, you've now not only ruled out B, you've ruled out anything else that's lower. So now you know your answer is A, and you're done once through the problem. Okay, we want to do this as a maximum of twice through a problem. Never want to go more than twice. All right, so let's do some examples. Let's do the first one on the page, SAT number 9. Zoe won a raffle at the fair. Good job, Zoe. She will receive the prize money in 5 monthly payments. If each payment is half as much as the previous month's payment and the total of the payments is $496, what's the amount of the first payment? All right, let's set it up. 5 payments, 1, 2, 3, 4, 5. And we know when we add them together, we're supposed to get $496. All right. Our question says, what is the amount of the first payment? That means one of those answers is the first payment. So again, start in the middle, either B or C. Which one do you guys want? Doesn't matter. C, start with C. Start with 84. Okay, I'm starting with 84. Each month is half as much as the month before. So if this is 84, what's the next one? 42 divided by 2. Well, goodness. Half of 42 is 21. Half of 21 is 1050. Half of 1050 is 5 1/4. Okay? All right. Obviously, this isn't going to be the right answer because this is going to be 75 cents and I don't have change over there. But add it up. Am I too high or too low? Too low. Yeah. Whatever it is, it's going to be too low. Okay. So if C was too low, then obviously D is going to be too low. You just ruled 2 answers out. Okay. Do you want to try A or B next? Try B. Okay. So B was what? 96? So 96, half of 96 is 48. 48 is 24, 12, and then 6. Okay, add that up. See if you can achieve 496. I don't think it's going to work. 24, 36. It's like 100 and something. Probably close to 200-ish. Okay, so that's not going to work. This is also too low. It's got to be A. Make sense? All right, let's do the next one. ACT number 2. If $600 was deposited in a bank account for 1 year and earned an interest of $42, what was the interest rate? Okay. All right, so our goal here is to get $42. That's our goal. Now, let's start in the middle with C. So, this looks like an interest rate problem, okay? And you guys learned a bunch of interest rate formulas and whatnot in school. You don't have to know any of those, okay? If they want you to use one of those, they'll give it to you in the problem. This is a straight up percentage problem. They just want to know what's 8% of 600. Like if we're using C, what's 8% of 600? So how do I figure out 8% of 600? Sir? True. Yeah, that's the other way around. If I'm plugging in my answers, then I want to do 8% of 600. Yeah. But yes, your method does work, sir. So if I do 0.08 times 600, I'm going to get $48. I want 42. That's too high. So if C is too high, you're going to rule out anything else higher. So rule out C, D, and E. You're left with A and B. So pick one and try again. Okay? So I would go to B just because I don't want to deal with the decimal. So 7% of 600. Yep, and that's going to give you your 42. So then you know right off the bat. That's got to be it. Okay. All right. That's how we do these. Again, we're plugging in our answers, okay? And again, I know, I'm well aware there are other ways to do these problems. I want you practicing these strategies, okay? And again, the reason is there are going to be problems you're going to encounter on both tests where this is the only way to do it. And I want you able to do this easily, okay? So the rest of this packet is yours to do for homework, okay? All right. Okay, back to your main packet. We're going to go to page 5 where it says math topics at the top. Vocab. Oh, who does not have an ACT book? Felicia, you don't have an ACT book, right? No, okay. Anybody else not have an ACT book? Okay. All right, let me make myself a quick note here. Okay. So vocab up at the top. There's a great vocab list in your ACT book. If you have the 22, you don't have to dig it out now, but if you have the 2022 edition, it's on page 244 to 445. And all the page numbers are listed depending on which edition you have up at the top. I want you to review that at some point. If you have any questions on the vocab, please see me, please ask. You know, you guys know how to find me, so contact me and let me know if you have any questions. Felicia, I will email that list to you. Okay. All right. Let's talk about positive, negatives, and zero. You guys know what positive and negative numbers are. You wouldn't make it into high school if you didn't. Zero is neither positive nor negative. Most people know that. Zero is also considered to be an even number. Okay, so how is that important? Why are we talking about that? In the last 6 to 8 months, these certain problems have been creeping into your SAT, and they are set problems. And set problems look like this. So it'll say something like set A, and then it'll have this funky epsilon. Epsilon means is comprised of. So set A is comprised of, and it'll say all even numbers. Then it'll say set B is comprised of, and it'll give you a list of numbers. So it'll just be a random list. Something like that. And it will ask, what is A intersect B? Okay, your answer choices will look like this. Let's see. And then C and D will be other stuff. That's obviously wrong. All right. So this is how they're testing zero as an even number. They're giving you set problems. They're telling you that set A is comprised of all even numbers. Set B is comprised of some random list. And then they ask, what is A intersect B? So the upside down U means intersect. So an intersection of two sets, that means where they overlap. Where are they the same? Okay. So if I'm looking for all my even numbers that are also in set B, again, if I know that 0 is an even number, then I know I have to have 0, 2, and 10. Those are my even numbers that are also in set B. Negatives don't count as evens. So 0, 2, and 10. So my answer choice has to be A. Again, this is an easy point if you know that 0 is an even number. So this is how they're testing the concept of 0 as an even number. And again, this is just starting to creep into your SAT. It's not on your ACT yet. I don't expect it to make it into the ACT. It's just not something they would test. Any questions on that? Okay. All right, so that's 0 as an even number and how they're testing it. Integers. Integers are positive or negative whole numbers or 0. Basically, if you think about a number line, your integers are the whole numbers that are on your number line. Okay. Prime numbers. Prime numbers are any number greater than 1, not including 1. 1 is not prime. Whose only whole number factors are 1 in itself. So for example, 5. The only way to make 5 is 1 times 5. So 5 is prime. The only way to make 11 is 1 times 11. So 11 is prime. Okay. All right. You got some brain exercises right there. Let's run those real quick. So list 3 integers, any 3 integers. 1, 2, 3 works. Negative 5,856,002. Those are all integers. Okay. Basically, as long as it isn't a fraction or a decimal. Number 2, what are the first 3 prime numbers? Be careful. What's the first prime number? No, there's one lower. 2. Yes, who said 2? Fabulous, sir. It is the only even prime number, and it gets forgotten. Okay? All right, so don't forget about it. First prime number is 2. What's your second one? 3. Yeah, I put 3 fingers up. I just realized I did it. I'd have it. Okay, what's your next one? What's your last one? 5. Beautiful. Okay, good. All right, what are the prime factors of 42? Now, that would require some brain power, so there has to be a shortcut. So let's look at the shortcut. The shortcut is to use a factor tree. We're going to use factor trees for a lot of things, so let's review those real quick. So, factor trees. Give me 2 numbers that multiply together to get 42. 21 and 2. We can do that. 2 is prime. 21. Break it down. 3 and 7. All right. And those are prime numbers. So the prime numbers that go into a number are going to be the numbers that are on the ends of your factor tree. In this case, 3, 7, and 2. And again, we're going to use that for a lot of stuff. So if you don't remember how to do these, I would suggest looking for a YouTube on factor trees. Because we're going to repeatedly use that. All right. SAT number 1. Let's look at how these basic concepts show up on a test. We got SAT number 1. If m equals 3, how much greater is 10m than 6m? All right, so this is a real basic problem. How much greater than means to subtract, right? We want how much greater is 10m than 6m. So 10 times m, we know m is 3, so that's 10 times 3. How much greater than means to subtract? 6m, 6 times 3. So this is, I can't multiply. 30 minus 18. 30 minus 18 is 12. So my answer should be 12, which is C. All right. ACT number 14 is a calculator problem. Which of the following integers is closest to root 50 over 2? Put this through your calculator. This is on here for 2 reasons. I need to know if you can use your calculator appropriately, and I need to know if you can round. Because I'm having kids with issues with both. Yeah, you're good. So when you do root 50 over 2, you should come up with like 3.5 blah, 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 blah stuff. Did anybody not get here? Because I'll happily come help you with your calculator. Okay. Yeah, phone calculator won't work. You do not have a square root button, my dear. Oh, you do, right there. Yeah. Okay. So do 50 and then hit the square root and then divide by 2.
Oh, okay.
That's the order you're going to have to do it in. Okay, you're probably in the same boat. Yep, there you go. That's what you want. Okay. Anybody else need calculator assistance? Okay, cool. All right. So yeah, once you get this one, then you just have to round. So we're rounding to the nearest whole number, so look next door. If it's 5 or more, you go up. So we're going to round this up to 4. Okay. If you need assistance with rounding, please let me know. I'd be happy to help you one-on-one later. Okay. You're not alone, by the way. And there's a whole 3 or 4 years of students right now that, for whatever, I don't know what happened, but for whatever reason, I got 3 or 4 years of kids right now that can't seem to round. So we'll fix that if it's an issue. All right. SAT number 2 at the bottom. Let's talk about that one. This is a Roman numeral problem. Let's talk about how we tackle Roman numeral problems. The way we do these is that we treat these like they're true falses. We're going to look at each Roman numeral and determine whether it's true or false. Then we're going to pick either the true answers or the false answers depending upon how the question's worded. Okay, so SAT number 2, which of the following must be odd? Okay, so our goal here is to get an odd number. That's what we're looking for. So Roman numeral number 1. We have an even plus an even. Give me 2 even numbers. Don't pick the same number. So 2 and give me another one. 2 and 4. That's my fault. I forgot to tell you don't pick the same number. So I got 6. Did I get what I wanted? Did I get an odd? No, so that's false because I did not get what I wanted. Rule number 2, I got an odd plus an even. So give me an odd and an even. 2 and 5? Okay, so I'm going to do 5 plus 2. That's 7. Did I get an odd? Did I get what I wanted? Yeah. Okay, something's true. Rule number 3 is, I think, an odd and an odd, right? Yeah. Odds. All right, give me 2 odds. 5 and 3. Sounds good. 5 plus 3 should be 8. Did I get what I wanted? No, fail. So the only one that's true is 2, so we're going to choose the one that says 2 only. 2 only is A, so choose A. Next page. ACT number 6. If x is a negative integer, which of the following will always be negative? You have letters in your answers. What do we do with letters in our answers? We pick a number. All right? Now, if we go back to the problem, it tells us what kind of number do we have to pick. X is a negative number, so we have to pick a negative number for x. So give me a negative x. Give me a negative number. Negative 4. All right, let's plug in negative 4. So A, we've got a negative x. So that's going to be a negative negative 4. That's positive. Negative negative x positive. So no bueno. I'm looking for something that's always negative. B, I got x squared. Negative 4 squared. Negative 4 times negative 4 is positive 16. If you are putting this in your calculator, you must put parentheses around the negative 4. If you don't, your calculator will give you negative 16. Fail. Okay. C, negative x squared. So that's going to be a negative negative 4 squared. Well, negative and negative makes it positive, so right there it's going to make it positive. Then you have to compute it. It's going to be positive. D. X cubed. Negative 4 times negative 4 times negative 4. Yeah, it's going to be negative. It's going to be negative 64. All right, so D can stay. E, we've got x plus 3. So that's negative 4 plus 3. That's negative 1. Okay, so D and E right now are staying. All right. Is there any situation, let's look at E for a minute. Is there any situation in which x could be a negative number, but E is going to come out positive? Yes, where? Negative 2 would work. Negative 1 would work. If x was negative 2 or negative 1, E is going to come out positive. And we're looking for something that's always going to be negative. So we can make E fail. It's got to be D. All right. Okay. ACT 47, this is a vocabulary review question. The greatest common factor of 2 whole numbers is 10. The least common multiple of the same 2 numbers is 120. What are your 2 numbers? Let's start with the first line. The greatest common factor of 2 whole numbers is 10. So what do those 2 numbers have to be divisible by? 10. They're going to be divisible by 10 if their greatest common factor is 10. So look at your answer choices. What can you rule out? A and B. Let's get rid of it. Be gone. A and B are out. So we're left with C, D, and E. Okay. The least common multiple of the same 2 numbers is 120. Okay, least common multiple. All right, let's start with C. Apparently they like least common multiple. Okay. So we have 10 and 20. Least common multiple can be calculated 2 different ways. One of the ways is to think of this like adding fractions together. So if you think of it like adding 1 over 10 and 1 over 20, then you want to look for your common denominator, okay? What would your common denominator be for 1 over 10 and 1 over 20? Oh God, fractions. Oh Lord. Anybody? Okay, so maybe this isn't the best way to approach this problem. So that was one way to approach the problem. If that way fails, we go to plan B. So plan B is actually to list out your multiples. So let's do that. All right, so if I count my tens, I got 10, 20, 30, 40, 50, etc. If I count my 20s, I got 20, 40, 60, etc. Yeah, it's 20. And you want the smallest number, the least common same multiple. So least common multiple, smallest number that's in each set. Okay? So smallest number that's in each set is 20, so your LCM is 20. Okay, which would also be your common denominator, by the way. So common denominator, least common multiple are the same thing. All right, so that takes care of C. C would be 20. Now if we go back to our problem, we want the least common multiple to be 120, not 20. So C is out. Oh, it's the same song from last week. Okay. D. D, we have 20 and 60. We're going to do the same thing. Well, we already got 20 listed out. Let's list out 60. So we got 60, 120, 180, blah, 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 blah. Again, lowest number that's in both lists in 20 and 60 is going to be 60. So their LCM for part D is going to be 60, because that's in both 20 and 60. So our LCM here is going to be 60. Again, that's not 120. So my answer by process of elimination has to be E. Okay. All right, the next set of problems, the next like 4 or 5 problems, all have to deal with remainder. Oh dear God, she said the word remainder. That must mean long division. And it must be doing long division by hand because calculators don't give you remainders. So when was the last time you did long division by hand? Like, oh crap. When I first started teaching SAT prep, I hadn't done long division in so long, I had to Google it. I was like, I'll be back with you in a minute. Hold on. I'm like, I do mostly trig and AP Calc. I haven't done that forever. All right. Okay. So SAT and ACT handle long division and remainder problems very, very differently. So we're going to look at how the SAT handles it first, then we'll look at how the ACT handles it. So the first two are your SAT problems. And you'll notice that they're non-calculator. Not that your calculator would help you. All right, so number 9. If m is divided by 4, the remainder is 2. What's the remainder when m plus 3 is divided by 4? Okay. So I need to choose a number m so that when I divide it by 4, I get a remainder of 2, so I get 2 left over. Okay? So I need to pick something for m so that when I divide by 4, I get 2 left over. What do you think? 10. Let's try it. So 10 divided by 4. Steps for long division. Divide, multiply, subtract, bring down, or dead mice smell bad. Helps you remember it. Okay, 4 goes into 10 twice. 2 times 4, that was our divide step. 2 times 4 is 8. That's our multiply step. Subtract. 10 minus 8 is 2. Bring down. I don't have anything left to bring down, so I'm done. My remainder is down here. So my remainder is 2. That's what I wanted. I wanted a remainder of 2. So yes, 10 works for m. Good deal. Good job. All right, so m is 10. What is the remainder when m plus 3 is divided by 4? So let's figure out what m plus 3 is. M plus 3 is going to be 10 plus 3. That's 13. So I'm taking 13 now and dividing by 4. So again, steps, divide. 13 divided by 4 is 3. 3 times 4 is 12. Subtract 1. I got a remainder of 1. And that's what I would grid in. Okay? It doesn't matter what you pick for your original m, as long as you initially had a remainder of 2, your final remainder will be 1. That's how this works. Okay, next problem, number 9, is yours to do for homework. All right, not number 9, I'm sorry, number 10. The one right after it is yours for homework. And we're going to do ACT 55 at the bottom of the page. Any questions on this? All right, ACT time. I like ACT problems with remainder better because they're more like puzzles. So ACT 55, when 7 to the 126 power is multiplied out, what is the digit in the ones place? All right, so I don't know about y'all, but first thing I did was I reached for my calculator because I had a big graphing calculator. I'm like, I'm just going to type this in my calculator. Well, if you type it in your calculator, it's going to say, overflow, error. Yeah. Which basically what it's doing is it's like, hey, that number's way too big, and you don't pay me enough to figure that out. So your calculator's like, no, I'm not doing that. So anytime you get an overflow error, you need to think pattern. There must be a pattern here. Any pattern problem is going to involve remainder. Okay, so if it's a pattern problem of any kind, days of the week, days of the month, anything like that is going to involve remainder. So let's look at 55. All right, so we're looking for a pattern this time in the ones place. So let's establish our pattern. 7 to the first is 7. 7 squared is 49. So far in the ones place I have a 7 and a 9. 7 to the third is 343. That's where my memory runs out. So I have 7, 9, and 3. 7 to the fourth is something I wrote down, 2401. So I still don't really have a pattern in my ones place, so I'm going to keep going. 7 to the fifth is 16807. 79317. I could be repeating if my next one is a 9. 7 to the sixth is 117649. Aha. Okay. So 793179. So my pattern is going to be 7931, 7931, 7931. Again, I'm just looking in the ones place. I don't care about the rest of the digits. Okay. All right. So my pattern is a pattern of 4. We're going to put a line there, kind of delineate that. All right. So there's my pattern. I've established how many things are in my pattern. Since I have a pattern of 4, I'm going to take whatever the large number is in my problem. In this case, it's my exponent of 126. And I'm going to divide by the number of things in my pattern. Now, I have to do this by hand because I need the remainder. And I'll show you how the remainder fits in a minute. So divide. 4 into 12 goes 3 times. 3 times 4 is 12. Subtract. Drop 6. 4 into 6 goes once. And I have a remainder of 2. Now, what do I do with that fun remainder? That remainder tells me what row in the pattern to go to. So if I have a remainder of 2, I'm going to the second row in my pattern. My digit in the ones place is a 9. So my answer is whatever the 9 is. I think it's E. Okay, so if I look at this in terms of remainder, this is remainder 1, remainder 2, remainder 3, but my last row in my pattern is not a remainder of 4. If I'm dividing by 4, I can't have 4 left over. My last row in my pattern will always be a remainder of 0. No matter what you're dividing by, the last row is always remainder 0. Okay. Any questions on this? Because if you take the ACT, you will see one of these at some point. They like their pattern problems. Okay. Next page at the top. ACT 45. Given today is Tuesday. What day of the week was it? 200 days ago. So we had a guy, I lived in a very small town in Iowa, and we had a guy who would frequent the bars at Haverns, and you could give him any date you wanted, and he would instantly tell you what day of the week it was. It took me forever to realize that the dude wasn't like brilliant. He was just really good at long division. Okay? He could figure out based on how many days ago it was, what day of the week it was, and then he would account for leap years. So he was just really good at math. He was a really bored farmer is what it turned out to be, but. All right. So I didn't realize how he did it until I started teaching SAT and ACT prep, and I'm like, oh, that's how he did it. So given today is Tuesday, what day of the week was it 200 days ago? We're still going to follow our same steps. We're going to establish our pattern, divide by the number of things in our pattern. So if today is Tuesday, we're looking at days ago, so we're going backwards. So we need to list out our days of the week, but we got to go backwards. So today is Tuesday, yesterday was Monday, and then Sunday, and then Saturday, Friday, Thursday, Wednesday, Tuesday, and then we're back to Monday. Okay? So again, just to kind of help myself out, I know this is going to be a remainder 1, 2, 3, 4, 5, 6, and then my last row is remainder 0. Okay. So it's 200 days ago. So I'm going to take the big number in my problem, which in this case is 200. I'm going to divide by the number of things in my pattern, which is obviously 7 days in a week. 7 into 200 goes twice. 2 times 7 is 14. It's 6, drop a 0. 8 to 60 goes 8 times. 7 is 56. That gives me a remainder of 4. So if I have a remainder of 4, what day of the week was it 200 days ago? It was a Friday. Okay. Got it? All right. Okay. Oh, how I knew what to divide by?
The remainders are going down the list, is that because it was 7 in the last question too?
Well, it's 7 days in the week here.
Yeah.
Right. So in the last question, we had a pattern of 4. So it was remainder 1, 2, 3, and then the last one's always 0.
Oh, okay.
Yeah, however many things are in your pattern, that's what you count to, except the last one's always 0.
Oh, okay.
Yep, no problem. All right, we got one more of these, and then we're done with this. All right, so your last one of these has to do with imaginary numbers, which everybody loves. So number 58, given a positive integer n such that I to the n is 1, which of the following statements about n must be true? Note that I squared is negative 1. All right, imaginary numbers. So imaginary numbers come in a pattern. And it's a pattern you need to memorize. Okay, it's only a pattern of 4. It's not bad. So here's your pattern. I to the first is just I. I squared is negative 1, which they actually give you in the problem. I cubed, well, that's 3 i's. So that's going to be I squared times I to the first. It's just the first two multiplied together. So I times negative 1 would be negative I. I to the fourth, that's 4 i's. So that's going to be I squared twice. So negative 1 times negative 1, positive 1. And then this pattern repeats. This will be the same as I to the fifth. This will be the same as I to the sixth, I to the seventh, I to the eighth, and on and on. 9, 10, 11, 12, etc. Okay, it just jumps back and forth. All right. So again, it's a pattern, right? So let me get rid of these guys just to make it simpler. So that means it's a remainder problem. So this is remainder 1, remainder 2, remainder 3, and as always, my last row is remainder 0. Okay? Now, in the problem, they tell me that I to the n is 1. Well, if I to the n is 1, which row am I in? Which row do I have to be in if I to the n is equal to 1? The fourth one, yeah, it's the only one that's equal to 1. So if this is true, then the only row I could possibly be in is the fourth row. It's the only one that matches up. So if I look at that fourth row, what do I know? I know I to the fourth is 1, and I know my remainder is 0. That's what I know about that row of my pattern. Yeah. You just start at 1, and you count up until you get to the last row, and the last row is always 0. All right, so I know I'm in the last row. I know my remainder has to be 0 in the last row. Look at your answers. The only one that says remainder is 0 is F, so your answer has to be F. Okay. Ma'am.
What determines what the last row is?
It's just the last row of your pattern. So like this, we know it repeats. I to the 5th is back up here. So wherever your pattern starts to repeat, the last value before it starts to repeat is your last row. So like the days of the week when we got the Tuesday down here, the next one would have been Monday back at the top. So we stopped at Tuesday. Okay, little note about K here that cannot be determined. I've had 2 answers in 15 years that could not be determined. So could it be your answer? Sure. Is it likely to be your answer? No, not at all. Okay. All right, you have 2 tables at the bottom there. Look over them when you get a chance. If you have any questions about them, let me know. And we're going to move on to the next page. All right. Tell you what, let's take a quickie break. Let's have a moment. Oh. Okay. All right. Okay, guys, we're going to try to kind of buzz through order of operations here. So what I'm going to do on page 8, you have practice problems up at the top with order of operations. I'm going to send you guys this packet with all of my work. I just want you to look through it. If you have any troubles on brain exercises 1 to 5, please let me know and we'll go over them together, okay? I'll hit you one-on-one for that if we need to. Let's look at ACT number 10. Let's look at how order of operations actually shows up on the test. Okay, so ACT number 10 is an absolute value problem. You got the absolute value of -6 minus 7 minus 41, like this. Okay. So for those of you that don't remember absolute value basically means it has to come out positive. Whatever's inside the bars has to turn positive when you take it out of the bars. So absolute value of -6, you're just going to drop the negative. That's just going to become 6. Now you do kind of treat them like parentheses though. If they have an operation on the inside, you got to do the operation first before you drop the negative. So we're going to do 7 minus 41 first, and then we'll evaluate the absolute value. So 7 minus 41, -34. I took more brain power than it should have. All right. And then -34, this negative that's on the inside is going to drop when I get rid of the absolute value, okay? The negative on the outside is going to stay. He's not affected. So this guy goes away. And I just have 6 minus 34, which I believe is -28. And that's answer choice B. Okay? All right, any questions on that? I have some people that have an existential crisis when they get a negative answer to an absolute value problem. But in this case, it's okay because the negative was on the outside. Okay. Cool. All right. Order of operation problems can also show up in word problems, and that's ACT 11 at the bottom. We have Samantha, Nyla, and Jerry own shares of stock in the Triumph Hotels Company. The shares of stock they own have a combined value of $6,880. Samantha owns 70, Nyla owns 50, and Jerry owns 40. What is the value of the shares Samantha owns? Okay, so keywords here, they have a combined value of $6,880. So that means we have to put it all together. Combined means to put it together to figure out how much each share is worth. Okay, so let's look at that. Let's look at total shares. So a share is just like a piece. Don't let the wording mess with you. So the total number of pieces in this pie, or the total number of shares, is 70, 50, and 40. So we got 70 plus 50 plus 40. Oh, mental math. 70 and 50 is 120, 120 and 40 is 160. So there's 160 total shares. And we know that those 160 total shares are worth a combined value of $6,000. can't write, $6,880. So we have 160 total shares at $6,880 total. Take 6,880 divided by 160. And that should give you the price of each piece or each share. Somebody run that in their calculator. Thank you. I'm like, we've reached the limit of my calculating capacity there. So each share is worth $43. We want the amount that Samantha owns, I believe. Yeah. So Samantha had Samantha had 70 shares. So she's got 70 shares at $43 per share. So 70 times 43. Thank you. I'm like somewhere over 2,800. So yeah, 73,010, which is your answer choice C. Let's see. All right. Next page is everybody's favorite. Fractions and decimals. Yeah. About that calculator. You don't get to use it for right now. So when it comes to fractions and decimals, you have to be able to do them without the calculator because of that non-calculator section on your SAT. Sorry, guys. Because the fraction button on the calculator is my favorite button. But unfortunately, you got to be able to do without. So a few quick bullet points here. Adding and subtracting fractions does require a common denominator. In other words, that bottom number does have to be the same. Multiplying and dividing fractions does not require a common denominator, so we like that better. Dividing fractions is the same as multiplying by the reciprocal. If you ever learned keep, change, flip, this is where keep, change, flip comes in. Reducing a fraction or writing it in lowest terms means dividing the top and bottom by the highest number that goes into both. If you don't know the highest number that goes into both, just keep dividing until you can't divide anymore. Converting between mixed numbers and improper fractions is important. It's probably something you've forgotten how to do, but that's okay. We're going to review it. Fractions and decimals between 0 and 1 behave differently. Okay, let's talk about this. So normally you multiply numbers together, they should get bigger. That's what usually multiplying does. You multiply by a fraction, it's going to get smaller. Okay, it's going to do the opposite. Normally you divide numbers, they get smaller. You divide by a fraction, at least something between 0 and 1, it's going to get larger. Okay, again, it's going to behave the opposite of the way most numbers do. Most people know those two. We're going to add two more. Squaring numbers. You square a number, 2 squared is 4. It got larger. You square a fraction, 1/2 squared is 1/4. It got smaller. Again, behave the opposite of what we expect. Square rooting numbers. You square root 25, it's 5. It got smaller. So square rooting numbers usually get smaller. Square root of fraction, the square root of 1/25 is 1/5. It got larger. 1/5 is bigger than 1/25. Okay, so again, behaves the complete opposite of what we're expecting them to do. Okay, so if you keep that in mind as you're doing fraction problems, it's a good mental check at the end. Did I get the right answer? Okay, did these numbers behave in the way that they're supposed to behave? All right, let's run some brain exercises real quick. Okay. Number 1, reduce 22 over 8. Okay, so reduce just means divide top and bottom. So the only number that goes in 22 and 8 is 2, so divide top and bottom by 2. 22 divided by 2 is 11. 8 divided by 2 is 4. Done. Nothing goes into 11 and 4. 2, convert to an improper fraction. So this is a mixed number, 7 2/9. And I want to change that to an improper fraction. An improper fraction is one that looks like number 1, where the top number is bigger than the bottom. That's an improper fraction. So to do that, think way back to grade school here, guys. You're going to multiply by the whole number by the bottom, and then add the top. So 7 times 9 plus 2. So 7 times 9 is 63. Add your 2 is 65. So 65 goes on the top. Keep that denominator. So 65 over 9. Your denominator indicates your piece size. You don't change the piece size unless you're multiplying or dividing fractions. Ooh, I'm going to fall over and lose a wall there. Second part of number 2. We got 5 4/7. So again, multiply by the whole number by the bottom, add the top. 5 times 7 is 35, add 4 is 39. So 39 and keep the bottom. Number 3, we're converting to a mixed number. So now we're going backwards. We have this piece, we want that one. We have 31 over 10. So here we multiplied and added. We're going backwards. So instead of multiplying and adding, we're going to divide and subtract. Sounds reasonable. So 10 goes into 31 3 times with 1 left over. So my leftovers form my fraction. And again, keep that denominator the same. Okay, 27 over 8. Same process. How many times does 8 go into 27? It goes in there 3 times. So my whole number is 3. And I have 8 times 3 is 24, so I have 3 left over. And my leftovers form my fraction. Again, keep that denominator the same. All right, so that was 1 to 3. Any questions on that? Cool. On to number 4. Number 4 says simplify, write in lowest terms. So we have 2 and 5/8 plus 1 and 7/8. So I'm adding, which means I need a common denominator, but they already have a common denominator, so I don't have to find one. You have 2 choices here. You can either turn these into improper fractions and then add and then regroup, or you can go ahead and add the whole numbers and the fractions separate, which is my preferred method because I think it's easier. So that's what I'm going to do. I'm going to add my whole numbers, 2 and 1. That's 3. Add my fractions, 5 and 7 is 12. And again, keep that denominator. And then I just have to simplify that. So I'm going to reduce the 12 over 8 first. So 12 and 8, 4 goes into both. So this is going to be 3. 12 divided by 4 is 3. 8 divided by 4 is 2. This is 3 and 3 halves. Now, I can't have a mixed number that also has an improper fraction. That's not right. So 3 halves. 2 goes into 3 once with 1 left over. So 3 halves is really 1 1/2. So now I just need to total up my whole numbers. 3 and 1 is 4. And then I have that 1/2 left over. So my final answer is 4 1/2. And again, if you don't like that method, change these into impropers. 2 times 8 plus 5. 1 times 8 plus 7. And then add. And then change it back into a mixed number at the end. Okay, whichever way your brain wants to do it is fine. As long as you get to 4 1/2, we're happy. All right. Number 5. We've got 5/8 minus 4/9. All right, we don't have a common denominator here. We need one. Easiest way to get a common denominator is simply to multiply the bottom numbers together. So 8 times 9 is 72. It may or may not be the lowest, but in this case it actually is. But it's the fastest way to do it. And again, time test. So 8 into 72 goes 9 times. Whatever I multiply the bottom number by, I have to do the same thing to the top. So 5 times 9 is 45. 9 into 72 goes 8 times. Whatever I do to the bottom, I have to do the top. 4 times 8 is 32. And then just subtract. 45 minus 32 is 13. 13 is prime, and 13 does not go into 72, therefore I can't reduce. That is my answer. If you guys have questions, stop me as I go, okay? You may have to yell at me, because I'm just going to keep flying through these. 2 and 1/4 minus 1 and 1/3. All right, so you have the option of subtracting these separately or subtracting them as improper fractions. Anytime you're subtracting with mixed numbers, I recommend you always change them into improper fractions. If you don't, you might run into the case where you have to borrow from the whole number, and that's a disgusting process. So change these into impropers. 2 times 4 is 8, add 1 is 9. 1 times 3 is 3, add 1 is 4. Find your common denominator. Common denominator for 4 and 3, just multiply them together, it's 12. 4 to 12 is going to be times 3. Whatever I do to the bottom, I got to do the top. 9 times 3 is 27. 3 to 12 goes 4. We do the bottom, I got to do the top, so that's 16. 27 minus 16 is 11. 11 over 12. All right. Thank God we're not adding and subtracting. Those are the worst. Okay. Multiplying and dividing, I don't need a common denominator. This gets a lot easier. Number 7. I got 3 over 8 times 11 over 12. You have two choices. You can multiply straight across and then reduce, but that tends to lead to large numbers when you're working with that calculator. So let's reduce first and then multiply. The way you reduce first is you cancel any number on the top with any number on the bottom. Doesn't matter what fraction they're on. So 8 and 11, nothing goes in 8 and 11, but 3 and 12, aha, they both divide by 3. 3 divided by 3 is 1, 12 divided by 3 is 4. And then multiply straight across. 1 times 11 is 11. 8 times 4 is 32. Your answer, you'll never have to reduce your answer if you do this, because you did your reducing first. Okay? So it'll save you time and effort. Number 8. Give that a shot on your own. So put that one down for homework. That is, that's mixed numbers. So you just need to put those into improper fractions and then multiply. All right. Number 9. You got 3/4 divided by 7/8. Okay, so 3/4 divided by 7/8. This is division. So division is your keep, change, flip situation. You keep the first fraction, you're going to change to multiplication and flip the second guy over. And again, cancel on those diagonals. 3 times 2 is 6, 1 times 7 is 7, and you're done. Okay? And number 10, again, I'm going to leave you to do that one for homework. They're mixed numbers. Change them to improper fractions, and then do your keep, change, flip. All right, let's look at number 11. Because everybody kind of freaks out with 11 and 12. 11, you have a fraction and a fraction. You have 2/5 over 3/4. Okay. Fraction bar just means to divide. So really what we have here is 2/5 divided by 3/4. That's the same problem. Okay? It's just the top divided by the bottom. 2/5 divided by 3/4. That's all this is. So now it's just a keep, change, flip situation. Keep your 2/5, change the multiplication, flip the second guy over, and multiply across. 2 times 4 is 8, and 5 times 3 is 15, and I can't reduce it. Okay? And again, try number 12 for homework. It's the same as number 11. All right, let's look at how fractions actually show up on the test. ACT number 3 at the top of page 10. Try that one on your own. That's for homework. Okay, it's pretty straightforward. We're going to look at SAT number 33, which is a gridded. Okay, so number 33 says, the table to the right shows the distribution of U.S. presidents according to century and region of the country in which they were born. Based on the info in the table, what fraction of presidents who were not born in the 19th century were born in the South? Okay. So we're looking for a specific fraction. Look for the word of. So what fraction of the presidents who were not born in the 19th century were born in the South? So whatever comes directly after the word of, that's going to be your denominator. So presidents who were not born in the 19th century, that's my denominator. Okay? So I want all the presidents not born in the 19th century. So I'm just going to cross out, in my table, I'm just going to cross out that 19th century column, that column in the middle. I don't need it. It's not part of my problem. Okay? So I have the first column, the 18th century, and the 20th century, the first and the last column. Okay, so this is a fraction problem. It's just a part over whole situation. So the part is what I want. What do I want? I want the people that were born in the South. So I want the presidents that were born in the South, of the guys I haven't crossed out, so I don't want to count my 19th century people, out of the total people I have left, the ones I haven't crossed out. Okay? All right. So how many presidents were born in the South of the guys that I still have left, the ones that I haven't crossed out? 12, the 9 and the 3. And how many total presidents do I have left that I haven't crossed out, the 18th and the 20th century? 24. If I total it the first column and the last column, I get 24. So I wind up with 12 over 24, which reduces down to 1/2. Okay. On these grid-in problems, you do not have to reduce your fractions. As long as it fits in the boxes, you're good. Okay. This particular one we would have to reduce because 12 over 24 will not fit my boxes. I'm going to have 1 box. I'm going to be 1 box short. Okay. But if I put in anything equal to 1/2, if I put in 3/6 or 4/8, it would be counted right. I could put in 0.5. It'd all be counted correct. Okay. All right. ACT question 16 at the bottom. Let's look at that guy. For the next school year, a college will use 1/9 of the money in its operating budget for library books and 1/6 of the money in its operating budget for scholarships. What fraction of the operating budget remains for other uses? Remains. That tells me I'm going to have to subtract at some point. So there's going to be subtraction somewhere in my problem. I just don't know where. Okay. So let's look at what they've used. Let's figure out how much they've used so far. So they used 1/9 and they've used 1/6. All right, throw that through your calculator. This is a calculator problem. Throw that through your calculator. Figure out how much they've used as a fraction. 5 over 18. Good, you know where your fraction button is. Okay. Should come up with 5 over 18. Okay. If you don't know where your fraction button is, if you don't know how to change a decimal to a fraction, see me after class today. I'll show you how to do it, okay? Pretty much all scientific and graphing calculators have a fraction button that will switch a decimal into a fraction. So they've used 5 over 18. We want to figure out how much is left, how much remains. Well, they have 1 whole budget. So that means we're going to be subtracting from 1. So what remains, you can read my horrible handwriting, what remains is going to be 1 minus what they've used, 1 minus 5 over 18. So 1 minus 5 over 18, again, you can do that in your calculator. 1 minus 5 over 18 should give you 13 over 18. So we have 13/18 of that budget left. Okay, and that's whatever answer choice that is, C. All right, ACT 37 on the next page, number 11. Or page 11, ACT number 37. For all real numbers x, such that x is not equal to 0, 4 over 5 plus 7 over x is what? I have letters in my answers. What do I do with letters in my answers? Right, and let's be smart about this one. What number could I pick that's going to make this problem really easy for me? 5. Okay? It's a number that's already in my problem, so I'm going to violate that suggestion of not picking a number that's in my problem because picking 5 is going to make me already have a common denominator and make my life much easier. So I'm going to go ahead and violate that suggestion on this one and take the risk. So if I plug in 5, I'm going to have 4 over 5 plus 7 over 5, which is going to give me 11 over 5. If you put that through your calculator, get yourself a decimal. That's also 2.2. So there's your target. So you're shooting for either 11 over 5 or 2.2. Okay? And we chose x equals 5. So plug x equals 5 into your answers, A through E. When you do that, the only one that should work for you is E. E is the only one that should give you either 11 over 5 or 2.2. Okay? All right. If you're having trouble getting that, again, see me after class. I'll help you get the buttons right in the calculator. Okay. All right, ACT 38. This is a long problem. So Harrisburg Rec Center recently changed its hours to open 1 hour later and close 3 hours later than it previously. We don't care. Residents of Harrisburg age 16 and older were given a survey and 560 residents replied. Again, we don't care. The survey asked each resident his or her student status, high school, college, or non-student, and what he or she thought about the change in hours, approved, disapproved, or no opinion. The results are summarized in the table to the right. What fraction of, there's that word of again. What fraction of these non-student residents, so the non-student residents is going to be my denominator, replied that they disapproved, there's my numerator, what do I want? I want to know how many disapproved of the change in hours. Okay? So who am I talking to in this problem? Am I talking to the high schools and the high school kids and the college kids, or am I just talking to the non-student residents? Who's important? Yeah, I'm just talking about the non-student residents. I don't care about the high schoolers, sorry guys, and I don't care about the college kids. So cross them out of your table. That data is totally irrelevant to the question they're asking me. So get rid of them, just cross it out. We don't need it. So you can cross out the first 2 rows, high school and college, they're gone. Okay, and then I would also cross out your totals at the bottom because they're no longer relevant and you don't want to accidentally use them. Okay, so with the data you have left, what fraction of the non-student residents, again, there's your denominator, replied that they disapproved, there's your numerator, of the change in hours? Okay, so again, part over whole. So my part is my disapproved, that's 353. And my total non-student residents should be 485 if you add all those numbers up going across. And they did not reduce that. Actually, I don't think that one does reduce. So it's 353 over 485, which is E. Okay. All right, SAT at the bottom, number 13. Which of the arrows in the figure points to the product of X, Y, Z? All right, what does the word product mean to do? What operation? Multiply. All right, so we're doing X, Y, Z. All right, look at your number line they gave you. What is the only letter that you know the value of based on that number line? Z, that's it. And what is Z? 1, which is absolutely not helpful whatsoever. So we have X times Y times 1. All right, now it does not say figure not drawn to scale. So therefore we can estimate. So give me an estimate for Y. Yeah, Y is probably about 1/2. I'm going to call it 0.5. So 0.5 times 1. Give me an estimate for X. 1/3. I'm going to call it 0.3 just to make my life easier. Throw that through your calculator. What's 0.3 times 0.5? 0.15. Is that bigger or smaller than X, which is 0.3? It's smaller, which means it has to be to the left of X. What's the only letter to the left of X? A. Your answer must be A. Which goes back to the fact that when you multiply fractions, it gets smaller. All right, guys, last section. Exponents. We can do this. All right. All of your exponent rules are listed up there at the top for you. So we're just going to run these real quick. Upper left, you have x to the a times x to the b, which is x to the a plus b. Now, you're used to seeing this with some numbers. So this is the same as like x squared times x cubed. That would be x to the 5th, okay? You're just adding your exponents when you multiply. If we add our exponents when we multiply, what must we do when we divide? So if we have x to the, which way did I put the letters? X to the a over x to the b. Then this is going to be a minus b. So if we have x to the 5th over x to the 3rd, we're going to subtract our letters. Or our letters. We're going to subtract our numbers. We don't subtract letters very well. 5 minus 3 is just 2, so this is x squared. Now if this was reversed, then this, you can either get x to the negative 2nd or x to the 2nd on the bottom, whichever way your brain wants to do that. 5 minus 3 is still 2. You just put it where the bigger number is, on the bottom. Okay, so that's the first row. Second row, x to the ab. All we're doing is multiplying. So this is like x squared cubed. So we multiply our two numbers together. This is x to the sixth. Okay. All right. Again, going across that row, we have x to the a, y to the a, and this becomes xy to the a. Now this is kind of a funky one. We're used to having the right side and going to the left. All this rule is saying is that we can go the other way. We can actually factor out this exponent. So this would look something like x to the third, y to the third, and this would become xy to the third. So you keep the exponent the same, and you just group the letters together. That's all that rule is saying. Okay. Negative exponents. So negative exponents, if you have x to the negative fourth, negative exponents are not happy where they are. If they're on the top, they're not happy, you need to move them to the bottom. If they're on the bottom, they're not happy, you need to move them to the top. Wherever they are, they're just unhappy. So if you have x to the fourth, that's like having x to the fourth over, or x to the negative fourth, it's like having x to the negative fourth over 1. It's not happy. Move him to the bottom, and then take away his negative because you made him happy. Okay? Now, if he's already on the bottom, so you have 1 over x to the negative third, again, he's not happy where he is. Move him to the top, and take away his negative because you've made him happy. Okay. Go across. Across from that, we have our fractional exponents and roots, something everybody loves. If I have x to the 3/4, okay. This is a top in, bottom out situation. The top number goes on the inside, x cubed. The bottom number 4 comes out. So this is the 4th root of x cubed. Okay. Let's see. Next up, we have the square root. So the rule on the bottom left, it looks really jumbly with all those letters. So let's make it easier. Okay. If you have the square root of x times the square root of y, this is just the square root of x times y. That's all that bottom left rule is saying. Now we can make this more complicated. We can put exponents on our x and y. We can make this x cubed and y to the 4th. Okay, well then this is x cubed and y to the 4th. It just carries from left to right. And maybe it's not the square root. Maybe it's the 7th root. Well, as long as they're both the same, then it just carries from left to right. That's all that bottom left rule is saying. Okay. Now, if we can do it for multiplication, we can do it for division, and that's the rule on the bottom right. So on the bottom right, we have the square root of x over y, and that's going to be the same as the square root of x over the square root of y. Again, I just broke it up. This is also how we do fractions, by the way. If I have the square root of 1/4, that's the same as the square root of 1 over the square root of 4. Okay, now, we can again make this harder. Maybe this is x to the 9th and y to the 6th. Okay, fine. This is x to the 9th and y to the 6th. Maybe it's not the square root. Maybe it's the 4th root. Okay, great. Then this is the 4th root and that's the 4th root. Again, everything just carries from left to right. That's all it's saying. Okay. The stuff down here at the bottom we're going to skip over. Again, I'll send that to you, and if you have any questions on it, let me know. Let's go to the next page. All right, let's look at how this stuff shows up on the test. Number 33 at the top. Which of the following is equivalent to, oh, that's a homework problem. What am I doing? 33 is a homework problem. ACT 25. For all a greater than 0, which of the following expressions is equal to a to the negative second? Okay, well that's just a negative exponent. So negative exponents we know aren't happy where they are. So he's on the top at the moment, so put him on the bottom. So that's the first thing I would do. And then I'm going to check my answers to see if that's there. If it is, then I know I'm done. If it's not, then I got to do something else. So it's there, it's E. So this is just answer E, and you're done. All right, SAT number 1. Oh, this guy. Okay, for the equations a to the x over a to the y equals a to the 10th. And ay cubed equals a to the x. If a is greater than 1, what's the value of x? Lovely. Okay. So you have two equations here. Let's start with the first one. Your bases are the same. Everything's a's. So that means if I'm dividing things that are the same base, then my rule is that I subtract my exponents, right? If I had x to the fifth over x to the third, I would do 5 minus 3. No different with letters. I'm still going to subtract my exponents. So x minus y, so a to the x minus y has to equal a to the 10th. Well, if my bases are the same, if my a's are the same, then my exponents are also going to have to be the same. Therefore, x minus y must equal 10. Just a little bit of logic. Okay. Right? No major math between here and here. It's just common sense. If my bases are the same, the exponents have to be the same. All right, let's look at the second one. We're going to do the same idea. A to the y to the third. Again, if I have this situation, I know I'm multiplying. So this is a to the 3y equals a to the x. And again, same kind of logic. If the bases are the same, the exponents are the same. So 3y has to equal x. You now have two equations and two unknowns. You can solve that using substitution or elimination. Okay? But this is set up for substitution. 3y is equal to x. So I'm just going to take this 3y, plug it in here for x. So that's going to be 3y minus y equals 10. 2y equals 10. So y is 5. But I believe they asked me for x. So if they asked me for x, if y is 5, then 3 times 5 is x. So x is 15. And that's my answer. And that's C. So that's how we get around that. Okay. SAT number 2 is yours to do for homework. You have letters in your answers, guys. What are you going to do? Plug in a number, okay? Make sure you pick a number for X on that one. All right, bottom of the page, SAT question number 6. Which of the following values of X is the square root of X greater than X squared? You have numbers in your answers. What are you going to do? Plug your answers in, see which one works, okay? So again, number 6 at the bottom is yours to do. And we got 2 more problems to do on page 14, and then we're done. Okay, so number 11 at the top, for a positive real number x where x to the 8th is 2, what is the value of x to the 24th? Okay, so they told you x to the 8th is 2. They asked you for x to the 24th. Okay, so look at what they gave you. X to the 8th. Look at what they asked you for, x to the 24th. How'd they get there? How did they go from 8 to 24? Times by 3. Okay. Well, in exponent land, if I'm going to multiply something by 3, that means I'm cubing it. Well, this is an equation. Whatever I do to the left, I got to do to the right. So whatever I do to the left, I do to the right. So that's going to give me x to the 24th is equal to 2 cubed. 2 cubed. 2 times 2 is 4 times 2 is 8. So x to the 24th is 8. And that's answer choice D. So look at what they gave you. Look at what they asked you for. How'd you get there? Do the same thing to both sides of your equation. That's going to come up again. Not at the moment, but it will come up again. All right, last one, number 12. Which of the following is an equivalent form of this cubed root of stuff? Cubed root of f of, oh Lord, let's try that again. That was a fail. Okay, so equivalent form. Anytime they ask you for an equivalent form and you have a root, that means to go to the fractional form. If they give you a fractional form and they ask you for an equivalent form, go to the root. Just go to whichever one is not the one they gave you. All right, so fractional form. We're going to do f, and it's got to be the inside over the outside. Okay, because again, our example was that x to the 3/4 is equal to the 4th root of x cubed, okay? The top number goes in, the bottom number comes out. So if that's our example we're working with, my top number is the number on the inside, so 6a. And my bottom number is the number on the outside, the 3. same thing with the k's. Top number is 2, bottom number is 3. And then just reduce 6a over 3 is 2a, and k to the 2/3. And that's D. Okay, the rest of your packet, all those charts and graphs problems from the middle of page 14 where it says charts and graphs to the end, they're yours to do, guys. They're pretty straightforward. All right, and I'll send you the answers midweek. Don't forget we have help sessions on Thursdays via Zoom, okay, at 8 o'clock. You all get that information by email every week. If you need help, come to the Zoom.